Le Chatelier's principle. So what is a stress on a system that is at equilibrium? So a stress is going to be anything that causes a change in the equilibrium. This is going to be due to a change in the concentration of a reactant or product. So maybe we add some product or add some reactant, or remove some product or remove some reactant. Temperature, so if we add or remove heat, that will impact the equilibrium. And for gaseous reactions, pressure can also impact equilibrium. Now, this stress is going to cause the rate of the forward or reverse reaction to change. It basically is taking the reaction out of equilibrium. This is because by doing any of these stresses to the reaction, we're going to change the number of collisions between reacting particles or molecules. So eventually, this reaction will establish a new equilibrium in order to relieve the stress, the impact that the stress has had on the equilibrium position. So we're going to talk about how each of these, concentration, temperature, and pressure, how each of these are going to impact a reaction that is already at equilibrium. So how do changes in concentration affect equilibrium? So if you add something, we're going to shift away to get rid of it. What this means is that if I add something, it's going to be more likely to collide and react and then produce the opposite side of the equation. So if we look at the reaction here, we see that we have CO2 as one of our products. So if I add some CO2, the reverse reaction will speed up and I'll produce more of my reactants because CO2 is a product. If you remove something, the equilibrium is going to shift towards it to replace it. So again, looking at this example, if I increase the amount of CO2, that means that the CO2 and the H2O are going to be more likely to collide together, and we're going to get more of my reactants. So we would say that we are shifting towards the reactants. If I were to remove some CO2, then the forward reaction would speed up so I could replace that CO2 that I've removed. Now, what about changes to temperature? So when you have a reaction that has heat in it, you're going to treat heat just like any other reactant or product. If you add heat, we're going to shift away from wherever heat is in the reaction. If you remove heat, we're going to shift to replace it. So looking at this reaction here, if I were to increase the heat by raising the temperature, that would cause my reverse reaction to pick up, and we're going to get more reactants here when we add heat. If we were to remove heat, then the forward reaction is going to speed up to try to replace that heat that we've removed. So adding heat would allow us to shift towards our reactants. Removing heat would allow us to shift to our products. Pressure is going to impact any gaseous reaction, and it's going to impact gases with uneven number of moles on each side. So let me show you an example of that. This reaction has 2 moles of product, whereas it has 1 mole of nitrogen and 3 moles of hydrogen, so 4 moles of my reactant. So if I were to increase the pressure, the reaction wants to relieve that pressure, and it's going to shift to whichever side has less moles of gas, because less gas means less pressure. If you decrease the pressure, we're going to shift to the side with more moles to try to make the pressure go back up. So if I were to increase the pressure on this reaction, either by reducing the volume or adding an unreactive gas, I'm going to shift to the side that has less moles to try to relieve that pressure. If I was to decrease the pressure, the reaction is going to try to respond in a way that makes the pressure go back up. So it would shift to the side that has more moles of gas because that will have a higher pressure. Now, catalysts are going to be things that speed up the rate of a reaction. They decrease the time that it takes to get to equilibrium. But it doesn't change the amount of reactants or products, the position of the equilibrium. It just makes us get to equilibrium faster. So the addition of a catalyst is not a stress on a chemical reaction. It just means that that chemical reaction is going to reach equilibrium faster. So here is a non-chemistry example. So this is a very simple reaction. I have chicken plus feed, and that yields eggs. And we're going to treat this as a reversible reaction. So don't look too far. Don't think about it too hard. This is just kind of a silly example to help illustrate some of these points. So if I were to feed the chickens more, I would be adding a reactant. So I'm going to shift away towards my products. So this is going to result in more egg production. Now, if you remove the eggs as they are laid, the chickens are going to see that empty nest and they're going to go ahead and lay more eggs. So by removing eggs, which is a product, the chickens are going to respond by making more eggs. So this is also going to lead to more eggs. And if you add more chickens, if there's more chickens, then you're going to get more eggs. So all three of these would be a stress on this reaction that would result in greater egg production.